Alright, so in this video I'm going to revisit the numeral that represents the number 6 and explain to you why I think someone used this geometric pattern to create the various designs of the numerals. So we're using a geometric pattern that is a series of consecutive square root radius circles, and each numeral corresponds to its circle in the series. So we're going to the circle with the radius of the square root of 6. So we know what the numeral for 6 looks like, so we're drawing that circle or tracing that circle. And then we're going to go to a point that defines that radius of the circle. This is important to realize that all of the lines that we use to create the numerals are attached to the points that define the radius of that particular circle. So we're going to go over the length of square root of 3 and up the length of square root of 3. A squared plus b squared equals c squared. So that gives us the square root of 6 on the 45-degree line. And we're going to go to a point just past that that has the coordinates of -1, 0.9, and then 1.9. So we're on the base 12 Cartesian plane. So that's basically 1 3/4. So 1.9, 1.9. Then we're going to use that point to start a line going up here at a 45-degree angle to this point, which has the coordinates 2.6 and 6. So we're at the length of 6 from the x-axis to here. So we've incorporated the precise length of 6. And as we draw this line, we're going through the midpoint of all of these units of 1. So that distance between these lines is 0.6, because 0.6 and 0.6 is 1 in base 12. 6 and 6 is a dozen in base 12. So now what we want to do is find out how long is that line. So what I'm going to do is take a piece of string, just attach it to that point, put my thumb here and swing it down, and we see it lands very close, if not precisely, on the length of 6 also. So this line also is very close to the length of 6, but it is going to be in units of square root of 2. So how long precisely is it? We'll do some base 12 math and just figure that out. So I've drawn a triangle here. The height of this is 1, 2, 3, 4.3, 4.3. So we're going to do a squared plus b squared again. So 4.3 squared is 106.09. So this length is 4.3 root 2. So 106.09, or square root of that, times the square root of 2 gives us square root of 3.16. So it's a little bit longer than precisely 6. 6 times 6 is 3 do in base 12. So if we do a little backwards figuring out, we see that the distance of 6.01 squared gives us 3.100, 6.016. So what we're doing is we have a length that's 0.6 or 6, and then we divide the next little square by 12, and we go 0.1 of that. We can see how close this length is to the